Guys, please stop talking, please pay attention. Roger! Done by? Alright, let's see if we arrive at that answer. Let's see if we can arrive at that answer. Thank you. Okay. Set this off to the side. Let's see if we get this. Let's see this what we arrive at. Alright, so let's work this problem out. Okay, so standard form, they say standard form is this, right? We know this, y equals ax squared plus bx plus c, so it's fully expanded, right? And nothing factored. All right, so if we expand this, it'll see you at the end of the period. It'll be safe. So let's be safe and let's know that we're going to write this as x minus 3 times x minus 3. That's what x minus 3 squared means, plus x minus 16. And then so from here, y equals, if we distribute, we say x times x is x squared, so we FOIL. And then we have x times negative 3, so minus 3x, and then inside minus 3x. And then negative 3 times negative 3 is positive 9, and then we have the rest here. We have plus 16, or plus x minus 16. Okay, away. Remember FOIL. First terms, outside terms, inside, and last. Each term is multiplied with each term of the other polynomial. All right, so we continue. Now what does this simplify to? This right-hand side of the equation. Do we see any like terms?
3x.
Negative 3x and x and
16.
well, hold on. All the x terms. Negative 3x. This one and the other negative 3x. Yeah. So here are all the x terms. Yeah. So we're going to go ahead and combine these. We are going to combine these three guys here. Okay. Now remember that, keep in mind that the negative is associated with the 3x. Sit here. Yep. So if I add these, negative 6x plus x is what? Negative 5x. And then 9 and the 16. Sorry, and the 9 and the negative 16.
Negative 5. No, negative 5 hit my bad time. I was thinking the wrong number.
Let's be careful. We gotta be careful here. So, like, sometimes I think about if I'm adding these two, 9 and negative 16. This is more negative. This is further away from 0 than this is, so I know my value is going to be negative. So what I'll do is I'll do 16 minus 9 and hold that negative on the outside. I say, okay, so minus 7. That's easier. We guys also have calculators, so you can just punch in the calculator 9 minus 16, so we don't make a simple mistake. And now this is fully simplified, or is it not? Can I go any farther than this? That's it. And the reason is because x squared term, an x term, and a constant. So there's no more like terms. And this is the standard form, ax squared plus bx plus c. So what would my a be? 1. B would be -5, and C would be -7. Very good. So the question that we're going to try to answer today is, how do we find the vertex and axis of symmetry of a quadratic in standard form? So yesterday we looked at what it was in vertex form. Yes? What's that? For where's that? This line here? This here came from when I multiplied x minus 3 by x minus 3. So when you have the two binomials, you have to, we call it FOIL. So yeah, x times x, x squared, x times -3 is -3x. -3 times x is -3x, and then -3 times -3 is +9. Good question. Any questions about this? Good? All right, so this would be the correct response. Sorry to erase your work, but I'm going to erase it. But I do appreciate the attempt. Who's lying to who? What's a lie? No. No. Okay. So we're going to try to answer that question. Let's review vertex form. Vertex form. So when we have it, when it's presented in this form, someone's got the giggles today. So when it's presented in this form, what is the vertex when it's given in this form? HK. HK, good. And what is the axis of symmetry?
Y.
X. X, yes, X equals H. X equals H, this is the axis of symmetry. What are you doing, Ryan? Well, show up really late and you're goofing around.
He's threatening me.
As much as I would like to do that, but
Alright guys, let's try to focus. I know it's Friday. Okay, vertex HK. Okay, there's no questions about vertex form. Alright, so when it's given on the quiz or test, so they'll have to do every single problem. Off. You know that? What? Oh my god, wait. Now I care, because that's hold on. Quiz or test. You mean the stuff that we're learning in this class is going to be on a quiz or test?
No, I thought you were giving us one right now. That's like...
Oh my god, just the words alone, you know. Okay, so state what form the quadratic function is in, vertex, standard, or neither. Find the vertex and axis of symmetry of the following quadratic functions. So that's what we're trying to do today. How do we find the vertex and axis of symmetry of a quadratic in standard form? These are all in standard form. Agree or disagree? Which ones are not in standard form? Yes, Trey.
the 2 on the right.
These two on the right are not in standard form.
No. The one on the bottom.
This one's not in standard form.
Don't listen.
No, you can say, I think, I'm not sure, but I think, yes.
So the very last one on the first row is in vertex form.
Okay. So this is vertex form. Is that the only one that's yes? Demetrius. Second one on the bottom here. This is not in standard form? It is standard form, okay. Right? AX squared plus BX plus C. Are there any ones that are not standard form? Yes, Hunter.
That one.
Which one?
That one. A of X equals.
G of X.
Yeah.
What form is that? Is it vertex, standard, or neither? See, I want to see. I'm testing your confidence level. You said vertex, and then I asked, was it that standard or neither? It is vertex. You're right. You're right.
You weren't confident.
I'm never confident.
Yeah. Again, you went when you said it at first, and you said, "Oh, never mind." But you were right. No, there's no one is made to look dumb in this class. This is where you make mistakes. Is now in the lectures. You don't make the mistakes in the quiz or the test. Make the mistakes now in the lectures. Raise your hand. I don't care if you try and you get it wrong while we're in class together like now during a lecture, but during a quiz or a test, that's when you don't want to make the mistakes. All right, so let's finish this form here. Standard. Good. Everything else is standard. Good. So, very good. You're juniors and seniors in a high school now, and you're still asking me if I should write things down.
No, I asked if I should write that down.
You're asking me during a lecture to write things down. You walk into a college classroom. Professor, should I write this down? No, you probably just like make a comment kind of along the lines that I'm making. But no, it wouldn't be that bad. Well, I don't know. It depends on the professor. I've had some that are real interesting. But yes, the answer is if you think I should write this down, if you think it's going to help you remember things, yeah, take good notes. Take good notes, guys. Okay, so does anyone remember the formula to find the axis of symmetry, or which is also the x-coordinate for these? Yes.
Would C be Y?
Would C be Y?
Yeah.
What's that C? Would this C here would be Y?
Well, I mean, like, for when you graph it.
Oh, the y-intercept.
The Y-intercept.
Yes, that is correct. This 3 would be the y-intercept for this one, and so would all the other constant terms that are by themselves for just look at standard. So the 3, the 11, and the 1. Good. Those would all be the y-intercepts. Okay? That's not what I'm asking. But that's a good point. That's a good piece of information that you're supposed to know, that you should intuitively know, because if I want to know what the y-intercept is of any function, I should be able to plug in 0 for x, and when I plug in 0 for x, whatever the output, the y value is, that is the y-intercept, right? Because any point on the y-axis, guys, Amanda, any point on the y-axis has an x-coordinate of 0. So again, I'll repeat it again. If I plug in 0 for my x's for any function, that should give me the y-intercept, if one exists. Okay? That's a good thing to know. But right now I want to focus on the axis of symmetry, which is the x-coordinate of your vertex. And there's a formula that I did mention, I believe, in the previous class, that the formula for standard form that gives you that. I'm going to start to write it and see if you guys say it as soon as you think you know what it is. It's x equals negative b over 2a. Does that sound familiar?
No.
No? Okay. All right. Okay. Sorry, maybe we didn't. But that's it. It's that simple. Negative b over 2a. This is the axis of symmetry. This is the axis of symmetry. And because it's the axis of symmetry, it is also the x-coordinate of the vertex. So let's do the math. Man, you guys, oof, having a good time back there. Having a good time.
Brian put in math.
I'll tell you, man, you know how to stretch it. You know how to stretch it. Let's do the math. What would the axis of symmetry be for this function here if we use that formula? See if we can figure it out as a class. Yes, Hunter.
Negative x over 2 times 1/2 x squared. Oh, just 1/2. 1/2.
Let's do this. What is the standard form? The standard form is f of x equals, what's the standard form of quadratic? Thank you, ax squared. Good, good. Just going down the line. Good. Okay. This is standard form. Sorry, I'm standing in some of your all's way. This is standard form. Okay. So when it says that x equals negative b over 2a, does b contain an x, or is b just the coefficient of x? Just the coefficient. Coefficient, again, that's the fancy word for the number in front of a variable.
-1.
Yes, 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 yes. Negative b would be -1, because b is 1, so negative b would be -1. And what is a?
1/2 squared.
No, a is not 1/2 x squared. We're looking at the first function.
Okay.
Hello? You have a pass?
Nope.
Oh. You just come from a shift from work? Oh.
No, this is
Oh.
contract species. No, I just got school.
You got what?
I just got school.
Oh, okay.
-1/2 times 16
Let's do piece by piece. Let's do piece by piece. What is a?
1/2.
Yes.
No,
1/2, sorry.
Guys, you're making this way more difficult than it is. It's giving you the puzzle. It's giving you, showing you what the pieces are. A is just a number in front of a x squared. That's all it is. That's all it is. B is just a number in front of the x. C is just a constant term in 3. That's it. That's it. So let's actually do it. Let's actually do it. So I hate to cram this up, but I'm going to do a little bit here. Let's do. Yeah, I hate to turn the page because we have that there, but I'm going to go ahead and turn the page. Y equals 1/2 x squared plus x plus 3. Okay. So the standard form is y equals. I'll have you guys repeat it again. What's standard form? It never changes. Ever, ever, ever. It'll be like this forever and ever and ever. Okay. Hello, Lillian. Do you have a pass? Why do you arrive so late? Personal reasons. Okay. Well, if you need to talk to me after class, please go ahead and do so. Could you come see me after class and remind me? I'm sorry, I forgot. Thank you. Okay, now do we remember axis of symmetry, the formula from the previous page? I just mentioned it. What is it? X equals negative b over 2a. Okay? So,
X equals
negative 1 over 2 times a is 1/2. If we simplify this, we have negative 1 over 2 times 1/2 is 1. And negative 1 over 1 is just negative 1.
Wait, but you guys said that for b is -1, but there's already a negative sign turning b into the negative again, so it's going to be negative 1. So it's going to be
Okay, so again, we're making this way more difficult than it is. We're making this way more difficult than it is. It tells you exactly what to do. It tells you exactly what to do. Yes. I can't.
Wait.
Yep. So the axis of symmetry is x equals negative b over 2a.
Okay. So fraction -1 over 2.5. I can get that.
We're going to get there. We're going to get there. We're going to repeat this again.
Okay.
So a is 1/2.
Okay.
B is 1, and C is 3.
Yeah.
Okay?
Yeah.
So I'm just going to plug that into the formula here. So x equals negative b. Negative b is 1. So negative 1 all over 2 times a, and a is 1/2. And then what I did was I simplified the denominator.
But why 2? We use 2 for everything?
Well, that's the equation.
Okay.
2 times 1/2 is 1. Negative 1 is still negative 1. Negative 1 divided by 1 is negative 1.
I get it now.
Okay, so this is the axis of symmetry. If someone can tell me the vertex of this, there'll be no homework with bell rings. If someone can tell me the vertex of this parabola, there'll be no homework for the weekend. Otherwise, check Blackboard. Check Blackboard.
That would be the x value.
That's the x. I want the y.
Okay, I got oh.
Oh my god, how do we do that? Oh my god. We have a function, the y in terms of x. Quickly, put the bell rings, no homework. Oh my god, I got the vertex. Oh my god, the vertex is -1.
3.
It's 3.
-1, 2, 3, 4, 5, 6, 7, 8, 11.
No, I'm not going to accept these guesses. I want a confident answer, yes.
-3.
1? Man.
You're just saying -1. So is it
That's the x coordinate. I need the y coordinate of the vertex. How do we do that?
3?
Oh, what?
Man, pencil and paper and all these students, and just to plug in -1 into here and just simplify, to not have homework for the weekend? Wow. Wow. Oh, someone's working it out. Yeah.
I appreciate that. Four and a half?
4.5.
4.5. What? Because it's okay, so it's -1 squared.
Wow.
Okay, and you do -1 squared, so then you square it, so it's going to be equal to positive 1 times 4 times.
6.
Check Blackboard for homework, because no one got that.
Hunter,
Out of all one, you couldn't just plug in -1 for x and simplify.
that's what I'm doing.
No, we have to not miss that
Two is not it.
I know, I was close though.
Plus doesn't count in that.